Hello students, welcome back to our channel Abhyas IIT Prep. So today we are going to learn about Jan 21st morning shift JEE mock analysis. Let's get into the video. So if you see that one, first question, the potential energy versus distance graph they have given. So if you observe what they are asking the magnitudes of the forces. So if we know that formula, okay, just wait. We know that formula, force is a negative gradient of the potential energy. Force is a negative gradient of the potential energy. By using this formula, we are going to solve this problem. Let's see this first curve 0 to B. Force of AB, what is the formula? Minus dV by dx. I am taking a magnitude, that's why dV by dx. So see here, VB minus VA by XB minus XA. If you observe in the graph, so we are having point A at 0 and point B at 1. So see here, point B 1 minus 0 by 1 minus 0. If you solve this one, we are getting value 1. So similarly, if you have to solve BC and FCD and FDE, so you will get the values. So option 4 is the correct answer. By solving these values, you are getting option 4 is the right answer. So next question 27. A gas based geyser heats water flow at a rate of 5 liters per minute from 27 degrees to 87. The rate of consumption of the gas. What they are asking? They are asking a rate of consumption of gas. So we are taking a rate of mass dm by dt 5 liter per minute. 5 liter per minute we are taking for kg per second. Kg per second. So see here, what is the formula for heat? Heat equal to ms delta T. So dm by dt specific heat and delta T is nothing but change in temperature. So see here, 5 by 60 into, they have given specific heat. They have given specific heat. 4200 into delta T. What is the change? 27, 87 minus 27. So you are getting 60. You can cancel out it. So what we have to take? The rate of consumption. Take it as the rate of consumption. Take it as X. So X times of heat of consumption is nothing but heat capacity, that is Q. So X times of 5 into 10 to the power of 4 joule per second heat, that is nothing but 5 into 4200. If you solve this equation, you are getting 0.42 value. What is the value? 0.42. So option 3 is the right answer. So see this next question. A conducting circular loop of area 1 meter square is placed perpendicular to the magnetic field which varies. They have given magnetic field equation. If the resistance of the loop 100 ohm, they have given the average thermal energy dissipated in this loop for one period. If we observe, this is a lengthy, little bit difficult question. So it will take much time. So all of you observe here how to proceed. We know that flux formula. flux phi equal to, I am writing here, please see, flux phi equal to BA, that is nothing but magnetic field into area. So magnetic field is nothing but sine 100 T into A, that is nothing but 1. So rate of change of flux is nothing but potential. Rate of change of flux is nothing but potential. So you can simply write it as 100 into cos 100 T. This is our potential. What is the power? What is the power? Power is nothing but V square by R. What is the V? We got this V. So 100 square cos square omega T by 100. Resistance they have given 100. So if we cancel out, we are getting power. What they are asking? They are asking average thermal energy. Average thermal energy in one loop. So how to get this one? So average thermal energy Q equal to integral 0 to 1 time period, that is the T, capital T. So P into dt. P into dt. We know that power. How to find it, this T? So time period, we know that time period T equal to 2 pi by omega. They have given in omega is nothing but 100 T. They have given omega is 100. So 2 pi by 100, you can simplify T equal to pi by 50. So you have to replace the T with 50. Okay, let's substitute the values. 0, pi by 50, 100 is there, 100 into cos square omega T into dt. We know that formula, cos square theta equal to 1 plus cos 2 theta by 2. I am writing here, observe, cos square theta equal to 1 plus cos 2 theta by 2. This is our formula we are going to use here. So 100 I am taking outside. So integral 0 to pi by 50 is nothing but 1 by 2 dt plus integral 0 to pi by 50. What is that one? Cos 2 theta. Cos 2 theta dt. What is that cos 2 theta? So here you have to write cos 2 theta is nothing but so see here, cos 2 theta. Okay, you have to write 200t. You have to write 200t. If you solve this integral, you will get a 0 because cos pi is always a 0. So from this one you are getting the answer. So pi by 100, that is nothing but pi. What is the answer? Answer is pi. So observe the next question. This is from mechanical properties of fluid, which includes the law of continuity and Bernoulli's principle. See that question. Water flows through the horizontal tube as shown in figure. Part A is there, part B is there. Take it as a 1 and 2, part 1 and part 2. The difference in height between the water columns in vertical tube is 5 centimeters. And the area of cross section at A and B are, they have given 6 centimeter square and 3 centimeter square. So what they are asking? They are asking a rate of flow. What is that? Rate of flow. Rate of flow is nothing but take it as a A1 V1. Rate of flow. Take it as A1 or V1? A1, V1. From continuity theorem, or law of continuity, A1 V1 equal to A2 V2. From this one you can simply write as 6 V1 equal to 3 V2. So from this one V2 can be written as 2 V1. V2 can be written as 2 V1. From Bernoulli's principle, P1 plus half rho V1 square equal to P2 plus half rho V2 square. We know that one. The pressure difference can be written as rho GH. The pressure difference can be written as P2 minus P1 can be written as rho GH. Rho GH. So I am writing here rho GH, that equal to half rho V2 minus V1 square. If you substitute the value of V2, you are getting rho gets cancelled, and the value of G is 10, height is 5 centimeters. I have changed it into meters. So we are getting 3 V1 square. 3 V1 square into half. If you cancel out this one, we are getting V1 equal to 1 by under root 3. V1 equal to under root 3. This is the centimeter per second. I am writing for meter per second. So what you have to find? You have to find the rate of flow. What do you have to find? You have to find the rate of flow. So rate of flow they have given already A1 V1 we have discussed earlier. So what is this A1? Area of first one. Area of first tube, that is 6 times of 100 by root 3. So from this one you are getting answer. So 200 times of root 3. I hope you are observing. So next one, see here. If you know the answer, please comment. So see here, what is the question? In an experiment, the values of two springs constant were measured as K1 they have given, K2 they have given. So if the springs are connected in parallel, So observe here. Take this one, spring 1, spring 2. They are connected with some mass M. We are not discussing anything about mass. Just I have taken mass. So take it as a K1 and a K2. What they are asking? Percentage error in spring constant. Percentage error in spring constant. So K equivalent is nothing but 10 plus 20, K1 plus K2, that is 10 plus 20, 30. 30 Newton per meter. So delta K equivalent or change in spring constant. So 0.2 plus a 0.3 is nothing but 0.5 Newton meter. What they are asking? Percentage error in equivalent spring. So percentage error. So percentage error can be written as delta K by K into 100. This is nothing but percentage error. So delta K, what is that delta K? 0.5 by 30 into 100. If you solve this equation, simplify this one, you will get one answer. If you know the answer, please comment below. So pause the video and comment below. So I am giving you answer 1.67 centimeter. Just cancel out. You will get the answer. So next one, see here, 31. A 4 kg mass move under influence of a force. They have given force. At origin t equal to 0. The velocity and position after time t equal to 2 seconds. Time t equal to 2 seconds. What you have to find? You have to find the velocity and position. So, if you observe here, if you want to find velocity, you must need acceleration. So, acceleration can be written as F by m. They have given force and they have given mass. So, acceleration is nothing but t cube I cap minus 3 by 4 t j cap. This is along x-axis and along y-axis. So, I am writing for velocity of particle along y-axis, rate of change of velocity. Rate of change of velocity is nothing but acceleration. Acceleration. So Vx can be written as, Ax dx integral 0 to, so dt, integral 0 to 2. What is the Ax? T cube. What is the Ax? T cube integral dt 0 to 2. So from this one you can write it as a t power 4 by 4. T power 4 by 4 at 0 to 2. At 0 to 2. So see here, from this one, what you are getting? You are getting 16. 16 by 4, 4. This is for x component. What about y component? Vy can be written as 0 to 2. What is this one? Minus 3 by 4 into t. Minus 3 by 4 t dt. So simply you can write it as minus 3 by 4 t square by 2 at 0 to 2. So simply you are getting 2 square, that is 4. 4 gets cancelled, minus 3 by 2 value. Minus 3 by 2 is the Vy value. So what is the final velocity? So final velocity can be written as 4 I cap minus 3 by 4, this 3 by 4, 3 by 2, 3 by 2 j cap. So similarly we are going to discuss the position. So we are having two options here. What is the options? 2 and 4. So you have to eliminate 2 and 4. So position, x-axis. What is the position along x-axis? So position is nothing but a rate of change of this position. Velocity is nothing but a rate of change of position, Vx. So from this one, x can be written as integral 0 to 2 Vx dt. What is the Vx? This is Vx, t power 4 by 4. T power 4 by 4. 0 to 2 dt. If you solve this one, t power 5 by 20 at 0 to 2. 0 to 2. So 2 to the power 5, 32 by 20. 32 by 20, you can simply write it as 8 by 5. 8 by 5. For y, position y, y equal to integral 0 to 2. What is y? Minus 3 by 4 t to the power 2 by 2. So simply minus 3 by 8 t square dt. So if you see here, minus 3 by 8 outside and t cube by 3 at 0 to 2. So t cube 8 and 3 gets cancelled. So you are remaining with 1. If you observe here, we are getting 8 by 5 I cap and 1 j cap. So what is the correct answer? So correct answer is option 2. Option 2. This is some lengthy question. So next question, see here. Consider modified Bernoulli's equation. They have given Bernoulli's equation. So if t has the dimension of time and then the dimension of the a and b. So first I am going with b because it is having h and t. So from dimensional analysis you can write like this one. So b equal to h equal to h equal to bt. You have to find b. So b can be written as h by t. If you write in dimension analysis, h is nothing but length, height, l inverse, t inverse. T is the time now. If you observe pressure P equal to A by B T square. You have to find a value of A by, what is B? L T inverse into T square. So what is the value of P? We know that value. So m L to the power minus 1 T to the power minus 2. This is the pressure. So if you cancel out, so L and L gets cancelled and T square and T to the power minus 1 cancelled, and you are remaining with t to the power minus 1. So A can be written as m L0 and t to the power minus 1. If you observe, these are the dimensional formulas for B and A. What is the equation? What is the option here? So option 2 is the right answer. So next one, see here, 33. A current carrying solenoid is placed vertically. A particle of mass with the charge q is released from rest. The particle moves along the axis of the solenoid. If the g is acceleration due to gravity, then the acceleration of the charged particle will satisfy. What is the condition between A and G? What they are giving? They have given one solenoid, one particle is there. The particle is moving vertically downward, If mass is m, the gravitational force can be written as mg, and velocity is in a downward direction, that is velocity. Okay, so see here, magnetic field for a uniform solenoid magnetic field is along axis. Is along axis. Magnetic field is along axis. So force due to magnetic field Q into V cross B bar, the theta is 0. Theta is 0. Then FB can be written as 0. FB can be written as 0. So force due to gravity, what is this one? mg. So what is the total forces acting on them? So FB plus FG, that equal to ma. So if this is 0, we can simply write it as mg equal to ma, g equal to a. This is our answer. A equal to Z. So next one, see here, 34, question number 34. A parallel plate capacitor has the capacitance C when there is a vacuum with parallel plates. A sheet having thickness 1/3 of the separation between the plates. The relative permittivity K is introduced between the plates. Then the new capacitance of the system. So we know that one, capacitance, capacitor, they have given like this one. So C can be written as A epsilon naught by D. A epsilon naught by D. D is the distance between them. So at this part, they have introduced one dielectric constant, that relative permittivity. So this is K. So what is the distance I am writing here? This is the d by 3 of a distance between the plate. If you observe, this is the total distance. It is a d by 3 and this is a 2d by 3. Take it as a C1 and a C2. C1 and C2. If you write a C1 equal to C times 3 by 2 times of the C. 3 by 2 times of the C. If you write a C2, 3kc. 3kc. So what is the equivalent capacitance? For two capacitors, C1, C2 by C1 plus C2. So if you substitute and solve this equation, you will get the answer 1. You will get the answer 1. 3kc by 2k plus 1. So next one, see here, one more question is there. Electric field, electromagnetic waves, from the electromagnetic waves. So what they are asking, they have given electric field in the direction of y. What they are asking? Magnetic field. What they are asking? Magnetic field. What is the difficulty here? Magnetic field along b axis, along y axis, you have to find first. So we know that formula, B bar equal to C bar cross E bar. C bar cross E bar. E bar they have given, that is along the J cap. What about C bar? So C bar is the along the current direction, that is nothing but x axis. In the x axis they have given in the x axis. So I cap. So I cap cross J cap, that is nothing but K cap. So no need to consider these two equations. No need to consider 3 and 4. So see here, amplitude of magnetic field is equal to amplitude of the electric field by C. C is nothing but a velocity of the light wave. So simply you can write it as 69 by 3 times 3 into 10 to the power of 8. You can simply write it as 23 10 to the power of minus 7. There is a change in amplitude only. There is no change in phase. Phase is remains constant. That's why option 1 is the right answer. Next one, see here. Question number 36. In YDSC, the distance between the slit they have given, separation they have given. One slit is covered with a transparent sheet of thickness T, refractive index they have given. The central fringe is shifted by 0.2 centimeter, the value of the thickness. We know that one. YDSC, we are having two slits of a screen. This is our distance small d and this is the capital D. Okay, one wave is going like this one. If we introduced one transparent sheet here of a thickness T and a refractive index mu, so what you have to find? You have to find this is our y. How to find the thickness? So we know that formula. What is the formula? Y, shift y equal to mu minus 1 times of the thickness into distance between the screen and the slits and distance between the slits. What we need? We need thickness. So thickness can be written as yd by mu minus 1 T into D. T into D. What is the y? So this screen distance. So mu they have given 1.5 minus 1, that is 0.5. Thickness, so I have written thickness again. I'm sorry for this one. Okay, see here, D, distance between the screen, so that is 50 centimeters. And what is y? Slits they have given 0.2, that is y, and 0.1, that is the slits distance. If you cancel out this one, you are getting the 0.8 into 10 to the power of minus 3. If you simplify, you will get the right answer 1. 8 into 10 to the power minus 4. So see here, next question. Question number 37. Light wave is described by, they have given one light wave falls on a metal surface of work function 2.8 electron volts. The maximum kinetic energy from the photoelectrons. What is the maximum kinetic energy? So see here, what is the K max formula? We know that formula. K max equal to K maximum equal to E max by 5, energy, maximum energy. So how to find energy? How to find energy? E equal to h nu. So how to find nu? Nu is nothing but omega by 2 pi. What is omega? Which omega you have to take? You have to take large omega, greater omega, as compared to this one. Take it as omega 1. This is omega 2. We have to take omega 2. So why to take omega 2? If you solve this omega 1, we are getting the energy is less than the work function. If you are getting energy less than the work function, there is no photoelectron ejection. So see here. So frequency can be written as here omega 1 to 10 to the power of 15 by 2 into 22 by 7. So you are getting 12.6 into 10 to the power of 90. 10 to the power of 90. Okay, see here. E equal to 6.6 into 10 to the power of minus 34 by in electron volts. We are taking in electron volts, that's why I am dividing with us minus 19. So just wait, this is not the exact value. So see here, if you find the energy, this is, if you find the energy, see here, if you find the energy from this equation, you are getting 12.6 into 10 to the power of minus 19. So substitute here 12.6 into 10 to the power of minus 19. So if you solve this one, you are getting 5.1 value, electron volts, 5.1 electron volts. So next question, if an alpha particle having energy 7.7 mega electron volts is bombarded on a thin gold foil, the closest distance from the nucleus. So law of conservation of energy, from the law of conservation of energy, so initial energy must be equal to final energy. Initial energy equal to final energy. So initial kinetic energy plus potential energy equal to K final plus U final. Initial kinetic energy 7.7 mega electron volts. Initial potential energy 0. Initial potential energy is 0. Final kinetic energy after bombarding, final kinetic energy is 0. Velocity is 0, then kinetic energy also 0. So 0 plus, what is the potential energy final? What is the potential? K Z E square by R. What is K? 9 into 10 to the power 9. What is Z? 79 into 1.6 into 10 to the power of minus 19 whole square by R. You have to find the value of the R. If you cancel out the things, you can simply cancel these things. Okay, 10 to the power 6 and 3. If you cancel out these things and if you find the R value, you will get the R value as 2 to the power 95 into 10 to the power of minus 14. 10 to the power of minus 14. Okay. Next question. This is very beautiful application from the rotational dynamics, rotational motion. What they are asking, a uniform rod of mass m and the length L is suspended by means of two identical inextendable light strings. The string one is immediate, the tension in one string immediately after other string is cut. The string is, one string is cutted, what will happen? So the rod will move like this one. It will move like this, rotate like this one. Okay. So in equilibrium, at equilibrium condition, torque at position B, torque at position A equal to torque at position B. At position A is normal torque, that is F into R. So what is the force here? mg. What is the R? Distance between the perpendicular distance. Perpendicular distance, that is nothing but L by 2. You have to take the, if mass is distributed over the length, you have to take the half of the length. So mg L by 2. What is the torque? I alpha, simply I alpha. So what is the I? So moment of inertia, ml square by 3 into alpha. What is this one? ml square by 3 into m alpha, alpha. So from this one, if you cancel out m and m, if you find alpha equal to LL gets cancelled, 3g by 2l, 3g by 2l. What you are getting? 3g by 2l. So see here, we know the relation between a linear acceleration and angular acceleration. Alpha is nothing but r, that is nothing but length, alpha equal to L by 2. From this one, if you write A equal to 3g by 2l into L by 2, you can simply cancel out and you are remaining with the 3g by 4. This is our acceleration. Why we are writing? You have to write the free body diagram of the length. So see here, free body diagram. If this is a tension, so see here, if this is tension acting along the string, and we are having magnetic force downward, gravitational force, not magnetic, gravitational force downward. So from this one, the acceleration in a downward, from here acceleration is downward. So mg minus t equal to ma. What do you have to find? You have to find the t. So t equal to ma minus mg, and if you take out m common, what is the a? 3g by 4 minus g. So what you are getting? You are getting mg by 4. So option 2 is the answer. Mg by 4. Option 2 is the correct answer. So next one, see here, an aluminum and steel rods are having same lengths and across the section they are joined together make a length of 120 centimeters at 30 degrees. If the coefficient of linear expansion, they have given linear expansion for aluminum and steel. So the length of the composite when the temperature is raised to 100 degrees centigrade. So delta L you have to find. Delta L is nothing but L naught 1 plus length of coefficient of steel into change in temperature plus L naught 1 plus length of the aluminum into delta T. If you simplify L naught, what is the L naught? Total length is 120. It is having equal length. That's why you have to take a 60 plus a 2 plus a alpha. What you are having? 24 into 10 to the power of minus 6. So 1.2 into 10 to the power of minus 5. I can write like this one. Okay. So from this one you can write simply 36 into 10 to the power of minus 6 into delta T. What is the delta T? Initial temperature 30 degrees, final temperature 100. What is the delta T? 70. What is the delta T? 70. If you simplify this equation, you will get the answer 2. 120.15. 120.15. That is your correct answer. So next one, see here, they have given one beautiful expression and a beautiful application here. So this is a 1 meter long rod is there. It is connected with a resistor 2 ohm as shown in figure. The area of circuit is perpendicular to the magnetic field of 0.1 Tesla. If the resistance of the total circuit is 2 ohm, they have given the force needed to move the rod towards the right with a constant speed of 1.5 meter per second. What do you have to find? You have to find the force. How much force is required to move that rod with velocity 1.5 meter per second. What is the force formula? Direct formula. So force equal to B square L square V by R. What is B? B is nothing but 0.1. What is L? L is 1 meter. What is V? 1.5. What is R? 2. If you solve this one, you will get the answer very clearly. If you simplify this equation, you will get the answer 7.5 into 10 to the power of minus 3. Minus 3 Newton. So option 4 is the correct answer. So next one, see here, 42. The given circuit work as. So A bar, B bar. So A bar plus B bar whole bar at Y output at Y equal to A bar, B bar, whole bar, whole bar. You can cancel these two inverse. So after this one, this is the condition for the NAND gate. Condition for the NAND gate. Very, very simple question from the semiconductor devices. So two strings of linear densities they have given. Two strings of linear densities. Lengths also they have given. Are joined together. The free ends of AB are tied to rigid supports. So two rods are there. They are joined together and tied to two rigid supports C and D. C and D. Creating a tension in 500 newtons. Tension is 500 newton. In the way, two identical pulses sent from the C and D take time T1 and T2 respectively to reach the joints. And what is the ratio of T1 by T2? What do you have to find? You have to find the time. What is the time? What is the time? So see here. We know that formula, velocity formula in strings. Velocity of A can be written as under root T by linear density mu A. So what is T? 500. What is linear density? That is a 2 into 10 to the power of minus 4. Okay, if you solve this one, you will get a 5 root 10 into 10 to the power of 2 meter per second. So similarly, VB, same formula. So tension, that is a 500 by mu B. What is the mu B? Mu B value is nothing but a 4 into 10 to the power of minus 4. If you simplify this one, you will get a 5 root 5 into 10 to the power of 2 meter per second. How do you have to find? You have to find the time. What is the time? So time is nothing but velocity equal to distance by time. So time can be written as distance by velocity. What is the distance? Length is the distance. What is the distance? Length is the distance. So TA can be written as distance. What is the distance? 2.5. 2.5 by, what is this one? 5 root 10 into 10 to the power 2. What is TB? TB is nothing but 1.5. length is 1.5 by 5 root 5 into 10 to the power 2. If you simplify this one, you will get the answer 1.18. 1.18. So correct option is 4. So next one, see here. Initially satellite of 100 kg is circulating around a radius of 1.5 r, that is the earth radius. This satellite can be moved in a circular orbit of radius 3r by supplying alpha into 10 to the power of 6 joules. Then find the value of alpha. What they are asking? What they are asking? They are asking the value of alpha, which is in energy. Which is in energy formula. What is the energy of satellite? Energy of satellite can be written as minus gmm by 2r. What is this r? R is nothing but a radius of the orbit. Radius of the orbit. Radius of the orbit. Okay, see here. I need a change in energy. This is negative. So energy final minus of minus plus initial. So what is the final energy? Minus g m by 2 times of what is the final radius? 3r. What is the initial radius? G capital M. Capital M is nothing but mass of the earth. So see here, 2 times of 1.5 r. If you simplify this one, you will get a gmm by 6r. gmm by 6r. So we know that one gravitational formula G equal to gm by r square. If you write like this one, gr equal to gm by r. Why we are writing? To simplify the equation, we are writing like this one. So delta E can be written as, so gm by capital R, capital R, capital M and G, removed by gr. So gr small m by 6. What is g? Gravitation, that is 10. What is r? They have given r equal to 6 into 10 to the power of 6. What is m? What is the m? 100 kg. So if you simplify this one, you will get the answer. So what is the alpha into 10 to the power of 6? Alpha into 10 to the power 6. We are having 1 6 here. So 6 gets cancelled. So 1000 into 10 to the power 6. This is the value of alpha. So option 4 is the right answer. So next one, see here, 45, question number 45. The point charge, they have given charge placed at origin. The work done in moving point charge 2 microcoulomb from, they have given point A and point B. Work done. What is work done? So work done is nothing but change in potential energy. Change in potential energy. We know that one. Potential energy is nothing but K. What is that? Q square by. We are having two different distances. That's why I am writing like this one. Initial energy final minus U initial. That's why 1 by R final minus 1 by R initial. So how to find R values? R final equal to, take this one, R final 2 minus 1. It is from origin. It is from origin. Square plus 2 minus 0 whole square plus 1. 1 minus 0. You are getting 3. So similarly, R initial 4 minus 0 whole square. So 4 square plus 2 square, you are getting 6. So substitute here, work done equal to K is nothing but 9 into 10 to the power of 9, Q square 10 to the power of minus 8 into 2 micro, 2 into 10 to the power of minus 6 by 1 by 6, 1 by 3. 1 by 6, 1 by 3. If you simplify this one, you are getting 6. You are getting 1 by 6. If you cancel out, you are remaining with option 3. Option 3 is the right answer. So next one, see here, this is the section 2, that is the numerical section. The collimated beam of light of diameter 2 millimeter is propagated along x-axis. The beam is required to expand in a collimated beam of diameter 14 millimeter using the system of two convex lenses. If the first lens is having a 40 millimeter focal length, then find the focal length of the second lens. So very simple formula is there. Magnification can be written as f2 by f1 d2 by d1. What is f2? Focal length. What is the d? Diameter. So you have to find f2. So from this one, f2, small f2, from this one, f2 can be written as, from this one, f2 can be written as f1 into d2 by d1. So what is the f1? Focal length 40 into d2. What is d2? 14 by 2. So simply 7. 280 is the correct answer. 280 is the right answer. So next one, see here. They have given one circuit. The heat generated in 1 minute between point A and B. Between point A and B. Between point A and B. So battery 9 volts they have given. Internal resistance 1 ohm. Internal resistance is 1 ohm. So if you observe here, this is Wheatstone bridge. This is 1 by 2. This is also 1 by 2. Wheatstone bridge, you can cancel this one. You can cancel this one. After solving this one, you will get one equivalent resistance, that is 2 ohm. And one more is there, internal resistance of 1 ohm. So total equivalent, R equivalent can be written as 3 ohm. So I is nothing but V by R, that is 9 by 3, that equal to 3 ampere. So what is the power? So heat generated, Q equal to I square R into T. I square R into T. What is I? That is a 9. 3 square. What is R? You have to take 2 only. You have to take the circuit resistance, R equivalent resistance. That is a 2. You will get 60. This is 160. Okay. If you simplify this one, 120 times of the 9, that is 1080. 1080 joules. This is the Q. So next one, see here, two identical mass they have given system. What they are asking, perpendicular to the plane of the rod. So they are asking value of the x. Just they are asking moment of inertia. So if you observe here, it is a passing through the edge. Passing through the edge. So what is the moment of inertia for this one? That is nothing but a total moment of inertia is nothing but a ml square by 3 down one. So next one, it is a passing through the edge. So you can simply write it as a ml square by 12 plus a ml square. If you simplify this one, you will get a 17 ml square by 12. So the value of x is nothing but 17. The value of x is nothing but 17. So very simple formula. The internal energy can be written as delta U equal to N CV times delta T. How to replace this CV? So CV can be written as Cp minus R into delta T. What is the delta T? Change in temperature 10. What is the number of moles? 10. So what is the Cp? 7. 7 minus 2. What is the R? 2. So this is also 10. So 10 into 10, 100. 100 into 5. So 500 is the correct answer. 500 is the correct answer. So microscope, they have given microscope. Objective lens is having focal length f0 equal to 2 centimeters, and eyepiece is having focal length fe is 4 centimeters. The tube length is 32 centimeters. The magnification produced by the microscope. What is the magnification formula? LD by f0 fe. L is nothing but length and D is nothing but least distance can seen by human eye, that is 25. So simply 32 into 25. Here 4 times, so you are getting 100. So under it 100 is the right answer. So this is our end of this session. So thanks for watching. So if you like our content, please subscribe to our channel. If you are having any doubts, please comment below. Thank you.